Okay, so we will now in this video look at some simple Julia programs to get started and slowly increase the complexity. So like studying any programming language, the first program you would like to write is a hello world program. So this is a simple hello world program in Julia. Let me make it a little bigger. Let me introduce the comment statements that you have in Julia. So if you want to comment any single line, or if you want to make a single line comment, this is how you do it. You put a hash symbol, and then we can write whatever statement you want. So first of all, the editor I'm using here is called Notepad++. You could use any editor you want. It's up to you. So this is the editor I'm using here, Notepad++. You can use a simple notepad editor or any editor that you're comfortable with. And we're not going to compile the programs through the editor. You're going to compile the programs through the command line. So you don't need to rely on any specific editor. Okay, so this editor I'm using, since I have saved the path, it is able to recognize that. And once I save this file as a .jl file, so you can see that I have saved it as a .julia file. So the way you can do that is type a file name and make the save as type as all types. If the Julia type is not showing up here, then you can say after as you type the name, you can make it .jl. So whatever the name you can give. And you can start with a numerical value. Like in this case, I do _hello world .jl. Okay, so you can do like that. So once you put the .jl extension, it's going to be recognized as a Julia file. And so it's just replacing it. So then the Notepad++ editor I have here is able to color code keywords and all the statements and all the commands and everything that are part of the Julia language. So this hash is the one-line comment thing. So if you want to make multi-line comments, Julia also does that. So this is the first line, say like that, and then second line and like that, third line like that, and then you can put something like this. So this is how Julia you can do if you want for neatness, you can do it like this. So this is how Julia organizes multi-line comments. So you start with, even it can be like this. So hash equal to, and then put whatever the, so it's not coloring for multi-line comments, that's okay. But you can see here, it's coloring the hash symbol here and the hash symbol here. So that's good enough. So it's recognizing this as a multi-line comment. So again, so comment statements won't be executed. So it's just for the user's understanding. So the only executable statement in this code is just this print line statement. So this is the way you print in Julia. So the print function is being called. And if you want to print and then require the cursor to go to the next line, you put an ln. If you don't want it to happen, you can just put print, and the cursor will stay on the same line. So ln is for a new line, for the cursor to go to the new line. So I'm going to show how this is executed. So as I said, fine. Um, so Julia one, let's go to helloworld.jl. And as I said in the earlier video, the first time you're running the Julia command, after a while, it could be a break during the day, after a few hours or something like that. It's going to take some time, even though it's a single line program. It's going to take some time to load into memory and then get the output. So because the the entire Julia environment needs to be loaded into memory. So now you run it again, it's going to be quick. You run it again, it's going to be quick. So that's what I want you to realize that if you run it after some time, the first time you run any Julia program, even though it could be a single line hello world program, it will take some time for the entire Julia environment to be loaded into your main memory and then the program to be executed. And then if you run the subsequent Julia the programs, whatever be the size of the program, it will run quickly. Okay. So that's the hello world program, and the print ln makes a difference whether the cursor stays on the same line or it goes to the new line. So let me see if I make it to print, what happens. So there's no separate compilation stage. So even though I say it's a compilation based language, you just run it all together, just like Julia, and then the file name. So order the name.jl. So make sure you have the .jl extension and then the Julia command. So since you don't see a difference. Let me say print another statement. So print hello world, and then let's see your name or something like that. Then you'll probably see the difference the cursor staying the same line. So now you see the cursor staying the same line. On the other hand, if you make it ln, and then if you make this ln as well, of course, the last print statement doesn't make a difference because the cursor is going to anyway print the new line. But you see here, I had left what do you call this blank space. So in the output, that blank space is getting reflected there. So you can see that it's showing up there. Okay, so that's this program. So I'm going to post. So let me show what I have so far in Canvas. So I'm going to post, so this here, I have a video of the syllabus overview, so I encourage you to go through it. And then I'm going to post some zip files of the code. So I'll probably number these. So as I said, I'll be numbering the code files from 0, 1, 2, 3, and so on. So you can keep track of what program it is using the numbers. And then I'll be using the numbers to show that this zip file has programs, say, from 2 to 10 or 1 to 10, whatever it is, and then another zip file from 11 to 20, something like that. Okay, so module 0 is basically a Julia tutorial that's going to have all these Julia code files to illustrate the different things that you need to know in Julia to do this course. So let's go to the second program here. So here, I want you to be able to enter a string. So I'm basically showing how to get inputs from the user. So getting a string as an input, getting an integer as an input, getting a real number, which is a float, as an input from the user, and printing them. So let's see how to do that. So again, here I have a multi-line comment. So I suggest before you begin any Julia program, you show the user what you're trying to do in that program. Okay, so I'm saying enter a name, and this is just a print statement, and it's going to wait on that line for me to enter some string. And any input that you enter to the command line is going to be processed or accepted as a string. Okay, even if you're entering an integer, it's going to be accepted as a string. Now, as a user, you need to know what as a developer, as a programmer, you need to know what you're expecting the user to input. So if you're expecting the user to input a name, it should be treated as a string as well. So you can right away assign the name equals read line. So now you can notice here one subtle thing is you're not declaring like in C++ or Java this name to be a string. You could if you want, and as you see here, then so there's a keyword called string, and it gets highlighted. So it's a keyword. But you are not required to explicitly declare it like in a C++ or Java like language. You can avoid declaring it. But since you are directly assigning, so the read line function is going to read a line of characters from the command line, and everything put together is treated as a string. So making that equal to, so that the name variable that you have declared here is going to be treated as a string, okay, because you're directly assigning to another string. So that's an implicit thing that Julia does. So from this line, the data type of this name variable is going to be a string, even though you have not declared it explicitly as a string. That's how Julia is going to treat it. If you want to explicitly declare this as a string, you could do it, and that's not going to be a problem. But the way data science style programming languages are kind of written, coded, or you don't need to explicitly mention the data type, like even that's what you do in Python. But Python is kind of dynamically typed, so you later in the program you can make this name variable to store an integer value. You cannot do that in Julia. Julia is kind of like C++, where it's strongly typed. So once it is considered is kind of being regarded as considered as a string in this line. For the rest of the program, this name variable has to be treated or used as a string. It cannot be used as any other data type. So the kind of the flexibility comes here, where you don't need to explicitly declare the data type. Depending on the value assigned to the variable, the data type of variable gets decided basically. So like here, so after this, you can print the enter, and let me show this in execution, and we'll go through it line by line. So CLS to go clear the screen. So this is Julia. I'm sharing space. So Julia, then two, this is a file name. So enter a name. So I can enter my name, and you can enter more than one word. That's fine. Everything is treated as a line. And I'm not printing anything right away. So it goes immediately after you press enter to this print statement asking enter age, and you write some age. Uh, so that is so that 48 is treated as a string. Okay. So once you press enter, uh, only after you press enter, it's going to be captured through this read line statement, and it's going to be stored as this string variable age string. Okay. So then what happens is you need to you know that this second input entered by the user is an integer. So as a developer, what you need to do is you need to convert that string variable to an integer. And this is how you do in Julia. So you can call a parse function, and the parse function takes two arguments. The first argument is the data type you want to convert this eventually into, and this is the current data type, which by default is a string. So the second argument is always going to be a string. This first argument is what you want it to convert, what that string you want it to be converted to. You could want to convert that string to an integer or to a float, as we'll do here. Okay, so in this case, you want to convert to an integer. So this is how you specify an integer. You could specify as int. And so the return value of this parse function then basically turns out to be an integer, and you're assigning that to this age variable. And again, I am not declaring that age to be explicitly an integer. That's not needed. But since the return value of this function is an integer, and you are assigning that to this age variable, from now on, this age becomes an integer. Okay. Then the third thing you're doing here is entering the weight. Again, the weight could be, say, some number like this. So again, it's treated as a string for now. Now you could realize that I could combine these two statements to one statement. I could instead have it as what I have here for this weight thing. Instead of creating a separate age string, or in this case, weight string or something like that, because the age string is basically storing what is returned from this read line function. So, and then it's being passed here. So instead of doing that in two separate lines, I could pass the read line itself directly to this parse function, and that's what I'm doing here. So this is a string here now, the third string entered by the user, and that's being really stored or returned to this readline function, and that's a string, and you want to convert now that to a real number. So real numbers here in Julia are represented using this float 64 data type. So you can now pass that as, again, these are keywords, float 64, int, int, and all these things. So you can now pass as the first argument for this parse function. So you see the argument is the keyword itself for the data type that's being passed here. So it's parse float 64 and then the readline function being called. So the readline function returns the string, that is that whatever the weight you have entered. And since the output of this parse function, and in this case is going to be a float 64, the weight variable from now on is treated as a float 64 variable. Okay, so that's how it is processed in this case, and now you can press enter. So then what happens? It's putting together all these things and sprint line statement. Now, Julia again has a flexibility like in C++ or Java, where you can add some text and then combine the variable values along with it and print as one output statement. And we have this flexibility here. And it's very simple as well. So let's say I want to print something like this, a doctor dr period and a space, and then my name. So I can do that. So anything that you want to insert as a text, you put within double quotes, and then you put a comma. And the space that you give here doesn't really matter, but the space that you give here within the double quotes does matter. So I give here a one blank space after the period symbol. So that shows up here, doctor period, and then this blank space. Then this is the name. So remember the name has the string that whatever the name the user passed. So that's there. And then you put a comma. And then again, this blank space doesn't really matter. You could make it any number of blank spaces. That's not going to show up in the output. But whatever you put now inside this double quotes is going to matter. So that's going to be just one blank space here, followed by this value of this age variable, which is 48. And then I want to display that it is 48 years. So I put a comma and then I put the years within double quotes. And I want a gap or blank space between the age, the value 48 and the years. So I insert that gap here as part of the years itself. And then a blank comma, blank space, and then the weight value. Now I could have had this blank space right here. So that's fine perfectly as well. Then I don't need the separate thing here. So both are going to be the same thing. Okay. Then the weight value, just say 140.5, and then the blank space here, and then the LBS. So then it gets printed, and that's nothing else in this code. Okay. I hope that's clear. So let's move on to the third program. Okay, so now here I'm going to show how to call functions in a Julia program. Now, unlike again C++ or Java, there is no explicit main function that's being there, and that's kind of the starting point of execution of a program, something like that in Julia explicitly again. But once you start having functions, in the programs that I've seen so far, we didn't have any function. We just had a bunch of print statements, getting inputs and printing them, and so on. So if you don't have any functions, then the first line is basically considered the starting point of the program. If you have functions like this, then the first line outside of any functions is considered as a starting point of the program. So in this case, I have just one function, and all functions. So again, the function is a keyword. So once you write function, you immediately, so it's like a beginning. So this function declaration itself is like the beginning block of the block, and end keyword is the end of that function block. So everything that you want goes inside that function block. Okay. And so this is the syntax. We'll come to that soon. So after this end, I don't have any more function. So whatever I write here is being considered as kind of the main block from which execution will start. Okay, so again, we don't need to explicitly declare anything called the main. Uh, Julia has the flexibility here as well. Okay, now, so let's go through this code and then we'll try to modify it and play with it. So this is a function that here will compute the volume of a cylinder, and this function is being called kind of like from the main block, which is again outside this function. So I asked the user to enter the radius, and we will slowly increase the speed from here because already I covered what all these input statements mean. So you're reading the same print, enter radius called readLine function. So whatever the user enters, it's read as a string, and you're using this parse function to convert that to a float 64 variable. So this R, this is the variable that's going to store the radius value, and it's a float 64 variable. So similarly, enter the height, and whatever the user is passing is read as a line, as a string, and then converted to a float 64 variable and stored as this height h. Okay, so R and h are the variable names here. And then you are printing a line, print line, and printing the text volume of the cylinder. And then you see here, I could call the function right away as part of my output as of a print statement. You don't need to explicitly make a function call like, copy it like this, and say volume is equal to something like this, and you would be probably just printing this. You don't need all those things, so you can avoid that. So basically, I'm trying to avoid creating a variable name and just call that function volume underscore cylinder. That's the name of the function I'm declaring here, and pass it to variables radius and height. So let's now go through this code for this volume underscore cylinder function and see what it does. So the volume underscore cylinder function, now again, it takes the radius and height as the argument. Now the variable names could be different or the same, but as you know, passed by value and all these things, this R is stored separately in memory, and this radius is kind of just getting a copy of it. And this height is getting a copy of that H value. Now, again, the implicit data type assignment here. So since this R and H are both float here, this radius and height are again treated implicitly as float 64 variables. Okay, so that kind of flexibility is there here. And then the formula for the volume of the cylinder is pi r square times height, pi r square h. So I kind of feed in that formula here. Now there is a keyword called pi. Don't need to import any statement. This pi is automatically available in the Julia environment. So the value of, so it's a keyword. So the value of the pi is 22/7 or 3.14 something. So you can make use of that automatically. And this is a multiplication star pi r square h. Then the r square or the radius square can be coded like this: radius raised to 2. So that's radius square. You can type radius times radius if you want to, that's fine. But Julia allows us to do like radius raised to 2 or radius raised to 3, whatever be the formula, you could do that. Times the height value, which is the height of the cylinder. We could do that as well. So this whole thing is computed by r square h, and then the value is returned from this function. So any function, if you're returning a value, you need to have this return keyword and then return the value. Now, you could have a lot of things inside this function. We are not entering any code here, but later in the bigger, more complex functions, complicated functions, we'll be doing a lot of processing, and then you could have a lot of statements and then return the value as the last statement within that function. So that volume is computed and returned here. So let's run this program as it is, and then we'll make some modifications to play with it. So Julia 3 underscore functions. Okay. So enter the radius. So let's say the radius is 5.4 something. Let's say the height is 10.2. It's going to compute the volume of cylinder as pi r square, which is 5.4 squared times height, which is 10.2. Now, let's say you want to add another function now. So how you could add another function is, now there's no rigid requirement that all function declarations have to be together, followed by this main block. You could do that for readability of your program. We'll do that first. And then you could also declare the functions in between. Okay. So let's start with the more traditional approach of writing programs, where I have all the function declarations together and then the main block. So let's say I want to find volume of a cone or something like that. So that also takes radius times height as the uh, arguments. And then immediately you can type the end. And the volume of the cone, if I remember correctly, is 1 by 3 pi r square h, right? So let me just check it. So volume of the cone, 1 over 3 pi r square h, if I am correct. Yeah. So let's do that. Now, 1 over 3 times pi times the r square, which is radius square. Now, since you have already fitted all these things in this editor, the Notepad++ is kind of has this intelligence of remembering those things. So you can do that right away instead of typing it if you, it kind of makes it easy for you. So let's call this volume of the cone is volume underscore cone r time comma h. And let's see what happens. Okay, so let's enter some radius as say 6, let's say some 10. So you could enter integers, but they're going to be treated as a float because of the way the program is written. All right, so this is pi r squared h. Let's use a calculator to verify the calculations are correct. So 6 times 6 times height is 10 and times pi, which is 22 divided by 7. So this is 1131. So it's a rounding error for the pi value. Okay, now let's do the cone thing. So pi r square h divided by 3, right? So that's this 3 coming here. So that's 377.14. Now, you should notice that I had it as just 1 over 3. So in a language like Java or C++, if you write it like just 1 over 3, it's considered as an integer division. And 1 over 3 will be basically 0 because that's the quotient, 1 over 3. So if you do 1 over 3 in Java or even in C++, it will just return 0 unless you explicitly make it 1.0 or a 3.0. So at least one of the numerator or denominator has to be a float, a double basically in Java C++ in order for the result of 1 over 3 to be like 0.333. In Julia, you don't have to do that. If you just specify 1 over 3, it's going to treat it as the way division is done typically. 1 over 3 is 0.333. Okay, and you can say times pi times radius squared times h. So that's why I wanted to check using a calculator to showcase that you don't need to do that explicitly. Julia will treat it as 1 over 3 is 0.333 and then do the multiplication. So it's, the answer is not going to be 0 because if you enter it as it is in a language where, let's say I declare even the radius and height as integer, and so 1 over 3 will be declared will be like a 0 in the high level languages. So that flexibility is there in Julia as well. Okay, now what I want to show is you could have this function declaration somewhere down here. and call this right here. So I'm not having the function declarations together. I'm having a function to find the volume of the cylinder, and I'm having some print statements, which is like outside the function block. So that's like the main block. So the execution is going to start from the first code written outside any function block. So execution is going to start from this print statement. And then let me close this a little bit because I'm going to use it anyway. And then the function to compute the volume of the cone is written here. And that's kind of after some few print statements. And then again a print statement. So this is perfectly fine from the point of Julia. So it's going to be executed. So let's say 7.5 and 14.2, and it's going to be executed as well. Now let's try even a strange thing, like I'm going to call it out after this print statement. So you need to press enter because it's a new line there. And to be recognized as the ending of the block. Let's treat it. Let's try. And okay, so this is where the problem is. So you cannot have the function declaration after it's being called. So this is where I'm calling from, print the volume of the code, but I'm having the function declaration after that. So that's not allowed in Julia. So you need to have the function declaration somewhere before you have that function call. So you could even have it right immediately above it or right along with the other function declarations. So all these are perfectly fine, but you cannot have it after the function call. Okay, so this is kind of how the error statements will start looking up in Julia. I don't like it that much, but after a while you will start decoding, be able to decoding it. So what it says is it's not able to understand what the volume underscore cone means, undefined variable error, but it's basically a function call. So it's not able to recognize what that function volume underscore cone means when we had that function declaration after the print statement. And so this is like the trace of the error. Like even in C++, we have a stack trace, or even in Java. So that's kind of what is happening here. And you could, okay, let me put it back here and run it through. Okay, so this is what we had for the core, for the compiler to output an error. Okay, so serious. All right. So enter the radius, enter the height. Okay, so the error happened in that the file name 3_functions.jl. This is the line number where the error is 18. So this is the line number 18 where I'm making volume underscore code, that function call. Okay, so using that error statement, you should be able to figure out in what line. So it'll appear like in this gray color here, where the error is, that line number. So you can figure out which line has that error. And then go back, okay, I have to call this volume underscore cone, but volume underscore cone is not defined before this function call. It's defined only after. So I have to move it to be called, to be declared before it's being called the first time. So this is perfectly fine. You could make it you could put the function declaration anywhere before that function call, and that should be fine. Okay, so I hope this is clear. Now we will do two more things and then we'll stop this video. Okay, all right. So I'm slowly increasing the complexity, as you will see now in this code. So this is again what we saw in this third program is a traditional function declaration where you have the function and the end key variable and then the name of the function and the arguments it takes and then the function body or the code inside the function. And then you already also saw that you could have other functions declared somewhere down the code. You don't need to declare all the functions together. Now moving one step ahead, uh, you can have something called an inline function that could be declared in Julia. that doesn't need to follow the traditional function and the keyword and then the end keyword and even the return keyword and all these things. It could be just defined as a single line. Okay, so let's go through this code. Now, if you just look at the statement here, it doesn't make sense what this basically does. So let's keep and go through this function, because this function, inside this function, I'm calling that earlier function, and it makes sense. Okay, so all this code does is try to solve the roots of a quadratic equation. Okay, so let me store that as well. The code is finding the roots of a quadratic equation. Okay. Um, so if you want to better read the code, you could even go outside all these function blocks from where the code outside of any function block starts is basically here. So the print statement. So I'm getting inputs from the user for three variables A, B, C. All these are read as float. So I'm kind of slowly see how I'm getting at a higher level because you already went through all the print statements in detail. You're reading as a string read line and converting that to an real number, in this case float 64, and storing it as A, B, C. And then I'm printing the roots are, and then calling this function quadratic solver A, comma B, comma C. So this quadratic solver is a function name, and you're passing three arguments to it, A, B, C. So this is a quadratic solver function and declared in the traditional way function quadratic solver. And I just label the same three names arguments here. And you know this is passed by value. So these are three different variables in memory. Just within the scope of this ABC here is within the scope within this function quadratic solver. Okay. So the formula for solving the finding the roots of the quadratic equation, if you remember, is minus b plus or minus square root of b squared minus 4ac, the whole thing divided by a. So that's kind of that formula here, minus b, and then again, so the two roots for a quadratic equation. So the two roots are like this, minus b plus or minus, and this is a square root term, where you have square root of b squared minus 4ac. And then this whole thing divided by 2 times a. And this is minus b minus square root of b squared minus 4ac, the whole thing divided by 2 times a. So that square root term is a common term in this root formula here. So I'm going to compute that. I could have written that square root of b squared minus 4ac right here like this. Uh, Let me just comment it out. So that's perfectly fine. It would be computed within this function itself, the square root of b squared minus 4ac. So the square root is again sqrt is a keyword. So it will be computed right here, assigned to the variable square root term, and then the value used up here. That's perfectly fine. But I want to illustrate the use of this inline functions. So that's why I'm computing it this way. So I'm calling another function find square root term. So that's what it looks like within this quadratic solver function. This find square root term is another function, and you're passing this a, b, c as arguments to that as well. So instead of declaring this find square root term as a traditional function, because I want to make use of the feature of inline functions that is available in Julia, I am saying find square root of term of a comma b comma c basically is going to compute and return this value. So I can say equal to square root of b square minus 4 times a times c. So that value will be computed, and this equal to sign serves as a return call of the value from this function. So whatever the value of this is returned here. Okay, so it looks like a variable assignment, like this, like it's a variable and this is the value of the variable, but it's not like that. It's basically a function call. And on the right side, you're basically computing some value, and to the equal to sign, you're returning that value as the return value of that function call. And that return value is now stored in the square root term and substituted here. Now, another beauty of this Julia programming language is this. Traditionally, you used to think that you can return only one value from a function, and that's what we did in the earlier program as well. You just returned the volume of the cone or the volume of the cylinder. That was just one value. But in Julia, you would be able to return more than one value as basically return values of this function. And the way you do that is simply like this: return R1, comma R2. So we're returning here two values, the two roots, R1 and R2, like this, and how to capture them. So in the print statement, it's not explicitly visible how we are capturing it. It's going to print. We'll soon see how it's going to print. But in order to illustrate how it could be captured, I'm calling it again like this: root 1, comma root 2 equals quadratic solver of A, comma B, comma C. So I'm capturing the first as return value as root 1 and the second return value as root 2, and I'm printing again print ln roots are root 1, comma root 2. So excuse me. So let me run through this. So this is Julia space 4. This is the function name. So enter A. So let's enter something for which we know there is real roots. Let's say I know. So if the equation is something like this, uh, so like x square, in this case ax square minus plus bx plus c. That's the equation, quadratic equation we're trying to solve. So let's say a is 1 and b is -1 and c is say -6. Okay, so this equation is going to appear like this: x square minus x minus x minus 6 equals 0. So A is 1, B is -1, C is -1. So all I'm going to do is input them. And this equation, let's solve it right away and we get the answer. The way you can factorize it is going to be like this. So this becomes x squared minus 3x plus 2x, which is minus x plus minus 6. So equals 0. So the x minus 3 equal to 0 or x plus 2 equal to 0. So the roots are x equal to 3 and x equal to -2. So this is what you should expect as an answer. So let's see you're getting it. So A is 1, B is -1, and C is -6. So you see here, this is how things are getting displayed. The first print statement, I didn't make any differentiation in the return value. So I just say roots are quadratic solver of A, comma B, comma C. And we know that function returns two values. So the two values are treated together as a tuple. We'll see later what a tuple means in a separate, it's like a collection of values. In this case, it's a two-element tuple. So it's just printed like this, the two values, 3 and -2, which we solved here as the roots of that equation. So that's how the first print statement comes to be printed. So roots are quadratic solver of 3, comma -2. Now, the second time I'm calling the same function, the same value, quadratic solver. I want to just see how what's the difference in the way things are getting printed. So this function again returns as 3, comma -2 as a tuple. So I am explicitly capturing them like using separate variables root 1 and root 2. So root 1 gets this value 3 and root 2 gets this value -2. Okay, so when I say roots are root 1 space root 2, they are treated as individual variables. So root 1 is 3, root 2 is -2. So you could, if just for curiosity, if you want to process these two as individual variables, yes. So let's say the product of the roots. The product of the roots is, what is the product of the roots? So you can say root 1 times times root 2 like this. And let's see whether it's multiplying them, because it's there now two independent variables. So you should be able to multiply them. 1, -1, -6, -6, yes. So there are two different variables now, root 1 and root 2. So we could multiply them. So this way, Julia allows the flexibility of having a function to return more than one value. And we could capture the values individually, the return values individually using separate variables. And then in this rest of this code, we can process them the way we want as individual variables. Okay, so it has a lot of such flexibility here. Okay. All right, let's do one more and then we can stop this video. So let's say we want to do some formatted printing. Okay, and now that we got to know this inline function, we can make use of that. So let's say I want to compute the volume of a sphere. So you see the syntax for the square root term here, the name of the function, and then you have to pass all the arguments, A, B, C in this case. Whereas now here, I want to compute the volume of the sphere, okay? And I want to do formatted printing. So I make use of this library called printf in Julia. So this is not explicitly available in a standard Julia code. You have to kind of like the include statements you write in C++ or import statements in Java. You have to include that library. So you say this using is the keyword that you have to call explicitly, and then use this call this function printf. All right, so again, this is an inline function call, so we can skip it and read the main block of code and then try to see how function is being called from the main block. So I'm printing enter radius and the read line, getting it as a read line string and passing that as a float 64 and storing it as a radius variable and calling println. So this is a normal println that we have seen so far. Volume of the sphere, calling the inline function sphere volume and passing that radius as argument. And this is being captured in this variable r, and you're computing it as 4/3 pi r cube. Now you could make it like simply like this, 4/3 as well. You don't, because I got used to traditionally of how you write in C++. So Java, so I wrote 4.0. But as you just saw, this in Julia, we don't need to explicitly do that. We just say 4/3 pi r cube. And that value is computed and it's returned here. So let's run it and see what's going on so far. And then we'll go from there. So this is Julia 5. Okay. So enter the radius. So let us say I entered something to be 9. All right. So we have not seen the last line so far. Let's see up to this. Volume of the sphere. So it's going to print that long set of decimal digits because I don't have any truncation here. I just, whatever it is, and it's a float 64. So it's going to be all those bunch of decimal digits. 4/3 times pi times 9 cube, and that's what this is, big number. Now, so I want the decimal digits to be kind of truncated to certain decimal spaces, and that's where the printf function comes into play. So again, remember here using, again, most of the times I don't myself use this printf. I just say println and get things printed. So but I just want to show in Julia, you could do formatted printing as well to this program. So remember this P here in the printf is a capital P, okay, as uppercase P. Whereas this is again a kind of like a keyword, how you make the printf or call the printf function. And this is how you have to call it. This is syntax at printf. Okay, that's a syntax for calling printf function. It's not like println, you put a parenthesis on the thing. You don't need a parenthesis or should not put a parenthesis. You just say at printf, and then the text what you want to print, volume of the sphere. So you want to print it like this, the volume of the sphere, and then the colon, and then the value. So where you want the value to be printed, that's where you specify the format. So you specify it as percentage. That's again a required symbol to be there to do formatted printing. And then this 0 represents whatever that value before the decimal space. So here this is 3053, 4 decimals, but we don't need to write 4 decimal spaces. So 10 is sufficient. It can allow any number of decimals before the decimal point. And then after the decimal point, you say 03F. So it means you are going to allow only 3 digits after the decimal point. And then this is treated like a print statement, the printf. So you want to go to a new line after the value gets printed. So that's why you put as \n. That's like how you do in C++ and Java itself. If inside a print statement, if you want after this printing, after this print statement, the control or the cursor to go to a new line, you put a \n, like the new line character, as the last thing within that text here. And then you should not write any comma here. Just call sphere volume, that's the function name here, and pass this radius. And then again, don't put this closing parenthesis here that goes with the beginning parenthesis. Here we don't have a beginning parenthesis here, so we don't have a closing parenthesis as well. It's kind of little weird way of calling a printf. I would have liked it to be like printf here and doing all this formatting here, but that's not the way the syntax is written in Julia here. So this is the syntax for the calling a formatted print function. Okay, so it's up to you. I may not require you to do format. Maybe later when we do some data processing, we don't want the output to be so crowded like this. So I may ask you to do a formatted printing. So it's good to know this, how to do a formatted printing. And so I have labeled the file names like this. So later down the semester, you want to come back and see how formatted printing is done. Then hopefully the file name will tell you which file sample code has that example like this here, and you can easily locate that. And also I'll be referring to you, okay, if you want to do formatted printing, refer to, that's why this numbering comes here. So it comes easier to locate using unique number. So file, refer to the program number, Julia number, file number 5. So you can go to file number 5, and that's where formatted printing is there. Okay. So hopefully this is helpful. Let's just change a little bit. Let's say I want to do just 2 decimal places, and let's see where it's going to reflect here. So yeah, so the same 9 I passed as radius. Now you see how the rounding is done. This is 6 to 8. So if I want to print it to just 2 decimal places, this 28 is being rounded as 30 basically, but you're truncating that 0, so just printing that 3. Okay. So if it was some other number, for example, let's hope it is now less than 5. So let's say I do something like this. So that's okay. This is even interesting to see. So 598 is being rounded. So 98 is rounded to the next value, just 100. But then this has to change to 6. So that's 60. That's how rounding is done. And okay, 6. So here is 0. So it's just retained as 6. So it covers all the 3 ways rounding could be done. Okay. So I'm going to stop this video with this.